Welcome to DENO-TECHNOLOGY. This is your home of learning electronics. Make sure you like, subscribe, and share with your friends.
Hello everybody, you're welcome to this channel. My name is Dennis. Today I'm going to take you through a calculation of how many solar panels do you require at your home or in your solar electricity connections. Suppose you have two batteries, each at 12 volts, 100 amps hour. So that means we shall be having, suppose you connect them in parallel, so that we get more current. That means we shall have the voltage will remain the same, which is 12 volts, but the current will increase. So the current will be 100 times 2, that is 200 amps hour. Okay, so that is for parallel connections. Now what if we connect in series? What if we connect in series? Now this is the battery, the two batteries, positive, negative, positive, negative. So series connection means we get this positive, this negative, and this one connects there. This one and the one we shall. So each is 12 volts at 100 amps hour, 100 amps hour. So the current will be 100 amps hour, but the voltage is going to be doubled because they're in series. So it's going to be 24 volts. That is the first thing you need to know. That when we connect in series, the voltage increases, but the current rating remains the same. When we connect in parallel, we have battery 1, battery 2. So we have here positive, negative, positive, negative. So parallel means positive will go to positive, then goes to the required point. Negative will go to negative, then goes to the required point. Here we see it is 12 volts at 100 amps hour. This one also 100 amps hour. Here the current rating is the one going to increase, which will give us 200 amps hour, but the voltage is going to be the same, 12 volts. When you bring your multimeter here, you measure the positive terminals, and at negative terminal we shall see that the potential difference across the battery will remain at 12 volts. So that's the first thing you need to know. Okay, let's go and get the real calculations of knowing how many solar panels you need. Okay, let's get to know how many solar panels you need. Assuming we have one battery at 12 volts rated as 100 amps hour. Okay, we want to know how many solar panels are required to charge this voltage. Suppose you are going to discharge it totally to 0. That means at 100% discharge. When it is fully charged, you first use it, it gets discharged totally to 100%, completely 0 voltage across the terminals of the battery. But it's not a good idea to totally discharge your battery, because you'll be overdraining the current, you'll be overstraining the battery, and very soon it gets spoiled very fast. So it's better to discharge it at around 80%, 70%, but for the purpose of calculation, we are going to use at a discharge of 100%. So at this point, we know that our battery, first of all, the battery is having 12 volts at 100 amps hour. So we shall calculate the energy stored in the battery. To get the energy stored in the battery, we are going to say 12 volts times the current rating, amps hour, which is going to give us 1200. The volts times the amps, that is watts. Then hour. That's how we get our unit of watts hour. That's the energy. Now, the next thing is we are going to get the performance ratio of the solar panel. And here, performance ratio of the solar panel depends on very many factors. The first factor is like the availability of sunshine, the temperature coefficients, the temperature of the sunshine, sometimes even the weather, can come and cover up. So the solar panel will not perform at 100%. Its performance will always reduce. Assuming now the performance ratio of the solar panel is 0.65. Okay? So we shall calculate the total number of, we shall therefore calculate the performance ratio of that solar panel. So for us to get the total number of watts required from the solar panel to charge the battery, we need to get the performance ratio, and we say the energy all over the performance ratio, which is the same as 1200 all over 0.65. So here we shall get 1846.15. It is still, this is the watt hours, so this is going to be watt hours. This is the total, this is the performance ratio, the energy required at this performance ratio of the solar panel. So now the next things, we are going to look at the total wattage. The total wattage of the solar required to charge this battery given these conditions, given this performance ratio, given this total energy stored in the battery. So to get that one, we shall say, assuming in a day you get abundant sunshine for like 5 hours. So we are going to say the performance ratio, which is 1846.15 watts hour divided by 5 hours. That is when you get, assuming you get sunshine, enough sunshine for 5 hours. So we shall cancel the hours. We shall remain with this, divide by 5, which will give us a value of 309.23 watts. So you need a total solar panel that will, a total watts from solar panel, a total watts of 369. So now to calculate the number of solar panels, number of solar panels will now be this total watts, which is 369.23 divided by assuming each solar you have, assuming each solar equals to 120 watts. So you will divide it by 120. This is watts, this is watts. So you want to get how many solar panel can bring this total number of wattage, whereby each solar panel is containing 120 watts. So when we calculate this one, we shall get, you need roughly to have 3.07, which is now 3 solar panels at each at 120 watts. But how are you going to connect these 3 solar panels, each at 120 watts? How are you going to connect it so that we get our 369? Let me show you. You remember when I told you that batteries, when we connect two batteries, let's use a symbol of a cell. When we connect two cells in series, the voltage increases, but the current remain the same. Okay. Now, when you connect the two batteries in parallel, or three batteries, depending on your choice, in parallel connection means positive altogether and negative all together. Here, the voltage will remain the same, but the current will increase. Okay, so the battery, the same format of connecting battery is the same format we are going to connect the solar panel. Remember, one solar panel equals to 120 watts, but we want to get 369 watts. So what we are going to do here is to connect these three solar panels, the one we calculate the three solar panel in parallel. So we shall say this is a solar panel, this is a solar panel, this is a solar panel. The positive terminal, negative, positive, negative, positive, negative. All these positive will be together. All this negative will be the solar panel. All the negative will be together. So that is how we obtain the total current of the total watts of 369 watts at the required voltage. So from today onward, that is how you should calculate the number of solar panels required to charge your battery, as we started from the beginning. Thank you very much. Make sure, you like, subscribe, and turn on the notification icon so that you get each and every video that I post.